This is ECE 2201 or the Advanced Engineering Mathematics for ECE online classroom. Welcome to our online class. Are you ready to learn? Today we will discuss the basics of complex numbers. Here are the topics under the basics of complex numbers. First, we will discuss the introduction to imaginary numbers and its power. Next, the complex numbers and the Argand diagram. We will also discuss the operations and properties of complex numbers and the different form of complex numbers. And for our final topic, we will discuss the powers of complex numbers. Today, you will need the following: scientific calculator, your activity and assignment notebook, a pen and paper, your attention, and your brain power. Today, you will learn the following: you will learn to evaluate the operations of complex numbers. You will learn to sketch complex numbers in the Argand diagram. You will also learn to evaluate different forms of complex numbers and evaluate the powers of complex numbers. It seems that you are now ready to listen to my lecture. Today we will discuss the basics of complex numbers. For our first topic, we will be discussing about the imaginary number. Imaginary number is denoted by the variable I. In engineering, it is denoted by the variable J because I represents the current flow in electric circuits. That is why in engineering we use J instead of I. But in our case, we will be using both J and I all throughout the subject. J is equals to square root of -1. That's how you define your imaginary number. What if now we will let J raise to a certain power? Our next topic is about the powers of the imaginary number J. Recall that J is equal to -1. Now, if I'm going to raise J by the power of 2, the result will be square root of -1 raised to 2, and that becomes -1. Now, if I'm going to raise J with the power of 3, that would be J squared multiplied by J. Take note, we know J squared is equals to -1. Now, if you multiply -1 to J, the result will be -J. That's for J raised to 3. Now, if I'm going to raise J to the power of 4, that becomes J squared multiplied by J squared. Or that is -1 multiplied by -1, that becomes +1. So this is the summary for the powers of J. Now let's have an example here. This time we are going to simplify the expression J raised to 20 plus J raised to 21 plus J raised to 18. Now what will be our solution here? Take note that we will be using the powers of J raised to 4. So J raised to 4 No? To make that j raised to 20, we raise that to the power of 5. For raised to 21, that will become j raised to 4 raised to 5, that's 20, multiplied by j, that becomes j21, plus j18. Take note, j18 is 16, right? That's 4 times 4, multiplied by, that's multiplied by j squared. That becomes j raised to 18. Now, take note that j raised to 4 is equivalent to 1, and 1 raised to 5 is still 1, plus j raised to 4 is still 1, multiplied by j, that becomes j, plus j raised to 4 is equal to 1, multiplied by j squared, which is equals to negative 1. Now, if we will simplify the expression, the result will be j. So meaning to say, j raised to 20 plus j raised to 21 plus j raised to 18 is equals to j. Now, try to solve this problem. Now, it's your turn. Try to simplify the expression here. Take note, guys, you have to pause your video and try to answer this problem. Simplify j raised to 27 plus j raised to 1999 minus j raised to 882. Now, I will give you 5 minutes to answer the problem here. Take note, you have to pause your video and solve this problem. You will be given 5 minutes only. Well, that's good. Your final answer would be, make sure you have solved the problem. Your final answer would be j1 minus j2. You read that as 1 minus j2. Did you get it right? Now for our next topic, we will be discussing the complex number. Take note, the previous problem resulted to a complex number. A complex number is a combination of a real number and an imaginary number. So in this topic, now we will discuss the complex number and the Argand diagram. The Argand diagram is just like your Cartesian plane where you can plot your complex number. So by definition, a complex number is denoted by the variable z, that is x plus jy. Take note, x here is the real part of your complex number, and y here is your imaginary part of the complex number. Now, if we will write it as real value of z, that is equal to your x. Now, that's our convention. The real values of z is equals to x, and the imaginary value of z is equal to y. Okay, this is your Argand diagram. Your Argand diagram is a two-axis diagram, just like your Cartesian plane diagram. You have your x-axis and you have your y-axis. Now for the Argand diagram, I will draw it. We will draw the Argand diagram here. That's your y-axis, and that will be your x-axis. Your x-axis is denoted as the real values Your y-axis is your imaginary value, and the intersection is your origin. Now, for example, I have a point here. The distance from the origin to that point, no, is equals to z equals to x plus jy. That is the representation of your complex number. Now the distance now of your complex number point to the real axis is equal to y, and the distance to the imaginary axis is equal to x. Now you form a right triangle. That is your right triangle. And the hypotenuse for your right triangle is what we call the magnitude of your complex number. We denoted that as the absolute value of z. That is the magnitude of your complex number. Now, the magnitude of your complex number can be solved using the Pythagorean theorem. And the magnitude of your complex number is is equal to the modulus of your complex number. That is x squared plus y squared raised to 1/2, or square root of x squared plus y squared. And the angle theta is equals to the argument of z, that is the same as the arctangent. Take note, no, that is the arctangent of the opposite over the hypotenuse or the adjacent, or that is the arctangent of y over x. That's the opposite angle of your theta and the adjacent angle of your theta. I mean adjacent side. Now, let's have an example here. We will sketch the complex number 3 plus j4, and we will solve for the value of the modulus of z. You can read that as the modulus of your complex number z and the argument of your complex number z. Take note, the modulus of z is the same as the magnitude of z, and the argument of z is the same as with the angle of theta. Now the solution here is to first sketch the axis. You have the real axis and you have the imaginary axis. And the intersection of that is the origin. Now from the origin, you have to write 3 that represents the real value and 4 represents your imaginary value. Now that point can be represented by z is equals to 3 plus j4. And the distance of your point to the origin is what we call your magnitude of z, or your modulus of z. And the angle between the angle between the magnitude and the real axis is your angle theta. So to solve for the magnitude, all you have to do is to use Pythagorean theorem. That is 3 squared plus 4 squared, and then take the square root. What will be the result? Yes, it's 5. Now to solve for the angle or the argument of z, that is the same as the angle theta, that is equal to the arctangent of the opposite, that's 4, all divided by the adjacent, that is 3. Using your calculator, you can calculate that as 53.13 degrees. Okay, now it's your turn. So I want you to pause this video and try to solve this problem. This is for you. You have to solve it for 5 minutes. Okay, it's your turn. Now, here comes the problem. You're going to sketch the complex number. Z is equal to 1 minus j. And then determine or solve the value of the magnitude and the angle theta. I will give you time. Pause the video. You have 5 minutes to answer the problem. 5 minutes only. So take out your calculator and your scratch paper and then answer the problem. All right. I think 5 minutes is over. Are you ready to show your answer? So what will be the value of the magnitude of z? What's your answer again? Right, your answer is equal to square root of 2. That is square root of 1 plus 1, and that becomes square root of 2. And for the angle theta, you have the arc tangent of 1, negative 1 over 1, that is equivalent to negative 45 degrees. Did you get the answer? Okay, our next topic is the conjugate of your complex number z. Take note, conjugate no, of complex number z is denoted by z bar. Now, if z is equals to x plus jy, what will happen to its conjugate? Its conjugate, no, that is denoted as your z bar, or what we call your z complement. Now that is equivalent to x minus jy. Take note, the sign changes from positive to negative. So to take the conjugate, you have to negate the imaginary, the imaginary value of your complex number. Now, if I have here your Argand diagram, this is your real axis and this is your imaginary axis. And this is your complex number x plus jy. Under that is what we call the conjugate of your complex number, that is equal to x minus jy. That's how you take the conjugate of the complex number. Okay. Now, for our next topic, we are going to, I will going to present some properties of the complex number. So these are the properties of complex number. First, if you are going to double conjugate the complex number, the result is still your complex number. Now, if we are going to add the complex number z to its conjugate, the result will be, take note, the result will be x plus jy, that is your value of z, and then x minus jy, that's your the conjugate of z. What will be the result? The result will become 2x. 2x is actually 2 times the real value of your z. Now, if you add z to its complement or to its conjugate, the result will be equal to twice of the real values of z. Now, what if we subtract the conjugate of z to your complex number z? The result will be twice of the imaginary value of z. For example, for number 4, Now, if we will add complex number z plus the complex number w, and we will take the conjugate of the sum, the result is the same as the conjugate of z plus the conjugate of w. Now, if we will multiply two complex numbers and then take the conjugate of the product, the result will be the same as the conjugate of each term multiplied together. That is z complement times w, z conjugate times w conjugate. The same is true if we will take the conjugate of the quotient. So the conjugate of the quotient is the same as the quotient of the conjugate of two complex numbers. That is z complement all z complement over w complement. For our next property, we have z complement raised to the power of n. That is the same as z raised to n. Then take the conjugate of them. So that is the conjugate of the power. Now, if we will multiply z to its conjugate, what will be the result? The result will be the square of the real values of z plus the square of the imaginary values of z. Now let's go to the operations of complex numbers. When we say operation, that is addition, subtraction, multiplication, and division of the complex number. Okay, let's proceed with the sum and difference of your complex numbers. Now, if I have here 3 minus j4, it's added to minus 6 plus j5, what will be the sum? So how are you going to solve that one? So in the sum and difference of the complex number is very simple. Okay, just group all the real values of the complex number. So that becomes negative 3. And then group the imaginary values, and that becomes positive j. For the product of z, okay, let's multiply this to complex number. So I have here 3 plus j2 multiplied by minus 1 minus j4. So how are we going to do that? So first, now we will multiply 3 and negative 1. The result will become 3. Then we will multiply 3 to negative j4, and the result will be negative j12. For the next term, we have j2 times negative 1. The result will be minus j2, and j2 minus j4, j2 multiplied by minus j4, take note, it becomes positive 8, because negative j times j becomes positive 2 times 4 is 8, so that's positive 8. So combine the real values and the imaginary values, the result will be 5 minus j 14. Okay, let's try to solve the quotient of 3 minus j4 all over 2 plus j. So how are we going to do that? First, we are going to copy the fraction, that is 3 minus j4, all over 2 plus j multiplied by the conjugate of your denominator all over the conjugate of your denominator. Take note, 2 minus j all over 2 minus j is just 1. So 1 multiplied to the fraction will have no effect to the fraction. So if we will multiply the denominator, that's 2 plus j multiplied by 2 minus j, the result will be 4 plus 1. For the numerator, that is 6 minus j3 multiplied, that will be minus 8j multiply minus j4 and minus j, that becomes minus 4. Now you are going to combine all the real values of z in your numerator, that becomes 2, and all the imaginary values of z, that becomes minus j11 all over 5. So you can write that as 2 over 5 minus j11 over 5. That's how you write your complex number. Now it's your turn. Try to solve this problem. These problems. Now, I will be making 3 problems. For problem number 1, I have your 5 minus j10 plus minus 23 minus j8. For problem number 2, I have 5 minus j multiplied by 4 minus j4. For problem number 3, you have 5 plus j10 all over 2 minus j8. So I will be giving you 15 minutes. 15 minutes to solve the 3 problems. So try to pause this video and solve the problem on your separate sheet of paper. Don't forget to bring your calculator during our class discussion. All right. Are you done? So these are the answers for the problems. So for problem number 1, you have minus 18 minus j2. For problem number 2, you have 16 minus j24. For problem number 3, you have minus 35 over 34 plus j 15 over 17. Did you get it right? Okay. Now we will proceed with our next topic. This time, I will be discussing the complex number in geometry. So in engineering, we have a lot of applications of complex number. in geometry. So let's try this one. Now, if you are going to add two complex number, no, using in geometry, you can label that as Z1. That's your first complex number. And your second complex number, now we will denote that as Z2. How are we going to find the sum? The sum is simply using the parallelogram method in your physics. Now you can have the resultant. The resultant of the resultant is actually the sum of two complex numbers if they are added together. So that will be the resultant. Now, how do we represent subtraction in geometry? Again, we will draw the complex numbers in the Argand diagram. You have here your real axis, and this will become your imaginary axis. So this is your first complex number, Z1, and then your second complex number denoted by Z2. Now, what if now we are going to subtract Z1 from Z2? What will be the resultant? Take note, Z1 is negative. So we are going to represent Z1 as negative Z1 by drawing or sketching another arrow to opposite to your Z1, that is your negative Z1. And then draw the parallelogram and then connect the intersection, and that will become the resultant if you are going to subtract Z1 from Z2. That will be the resultant. Now we have more applications on that later on. Okay, our next topic is the polar form and the rectangular form of a complex number. Take note, the rectangular form can be written in the Argand diagram. Now, this is how you represent your rectangular form. You have z is equals to x plus jy. Now, that point, now the distance of that point to the x to the real axis is equals to y, and the distance of the point to the imaginary axis is equal to x. And the hypotenuse is labeled as r, or that is the magnitude of your z. Now, if we will solve for y, that is just equal to r sine of the angle theta. To solve for x, that is just equal to the sine of the cosine of the angle theta multiplied by r. So for the rectangular form, take note, we can write that as x plus jy. That's how you represent your rectangular form. For the polar form, you can write that as r angle of theta. Take note, in some references, rectangular form is also known as the Cartesian form. Take note that the r is equivalent to the magnitude of the complex number z, that is square root of x squared plus y squared. And the angle theta is equal to the arctangent of y over x, or that is what we call the argument of your z. Okay, let's have an example here. So in our example, we are going to convert the rectangular form of the complex number to its equivalent polar form. So we will convert z is equals to 4 minus j3 to its equivalent polar form. So how are we going to do that? First, now we will draw we will represent this complex number in the organ diagram. That is your real and imaginary axis. So that's your 4 is actually your real value and your imaginary value 3. Now if you are going to connect the points, now from the origin you can form a right triangle with an angle of theta, and the hypotenuse or r is equal to the magnitude of your complex number. Now to solve this problem, all you have to do is to solve for r, which is equal to the magnitude, that is the square of 4 plus the square of negative 3, square root of that will become 5. And to solve for the angle theta, that is equivalent to the arc tangent of the imaginary part all over the real part. Now take out your calculator and solve this one. Make sure your calculator is in degree mode. So what will be the result? That is negative 36.87. So the the rectangular form for minus j3 is equivalent to z 5 z equals to 5 angle of minus 36.87 in polar form. So we can also check this using your calculator. Please take out your calculator. So follow me. Press shift and then find polar in your calculator, that is shift plus sign, and then write the real part, that's 4, and the imaginary part, and then press equal sign. And then the result will be 5 angle of negative 36.38 degrees. For our next problem, we are going to convert the complex number in polar form to its equivalent rectangular form. So here is the problem. Convert the complex number z is equals to 2 angle of 940 degrees to its equivalent rectangular form. So what will be our solution here? So we will start our solution by sketching the complex number to the organ diagram. So I have drawn the first revolution, that is 360, another revolution, that's 360, a total of 720 degrees. What is lacking? So another 220 degrees, that's 180, plus 40 degrees, that becomes 220 degrees. So this is how you draw your polar form, your complex number in polar form to the organ diagram. Take note that is 2 angle of 940 degrees. And this angle up to up to that point is equivalent to 220 degrees. Now, we can rewrite this now as 2 angle of 940 degrees to its equivalent form, that is in general form, that's 220 degrees plus the 2 revolution. So that is actually equivalent to 940 degrees. So you can simplify this to 2 angle of 20 degrees, removing 2 times 360 degrees. They will result they have the same result. Now, instead of using 940 degrees, we will use 220 degrees. So to solve for x, to solve for the real part, we can have 2 cosine of 220 degrees. Use your calculator. What will be the result? That's 5, negative 1.53. We also have the imaginary part. So use your calculator. To sine of 220 degrees, the value becomes, in your calculator, that's 1.29. So you have now your rectangular form. The rectangular form is negative 1.53 minus j 1.29. That will be your final answer. So you can check that using your calculator. Go to Shift, press rectangular form, copy the magnitude 2 and the angle 940 degrees. The result will be negative 1.53 minus j 1.29. So in our subject, you know, you can round off your final answer to up to 2 decimal places only. Now it's your turn. So try to solve this problem. So you are going to convert to polar form this complex number 2 minus j7 and convert to rectangular form the complex number z is equals to 3 angle of negative 1210 degrees. So you will be given 10 minutes to solve the problem. Ready? 10 minutes is up. So the answer for problem number 1, make sure you have paused the video to solve the problem first. So the answer for problem number 1 is 2.28 angle of negative 74.05 degrees. The answer for number 2, z is equal to negative 1.93 minus j 2.30. Did you get it right? Are your answers okay? Okay, let's proceed to the next topic. Our next topic is the exponential form of the complex number z. Now from this Argand diagram, the real axis, imaginary axis, you have your complex number z is equals to x plus jy. You have your radius r, you have your y, and you have your x. And r is equals to sine of theta. So our theta is the angle here, and x is equals to r cosine of theta. So in rectangular form, you have z equals x plus jy. In polar form, take note, no? The value of z in polar form is equals to r angle of theta. Now in exponential form, you can denote that as, take note, z is equals to r angle of theta. You can write that as r cosine of theta plus j r sine of theta. If you are going to factor r, the result will be r multiplied by cosine theta plus j sine of theta. And cosine of theta plus j sine of theta is actually your Euler's identity. This is your Euler's identity. So meaning to say, cosine of theta plus j sine of theta can be represented as e raised to j of theta. So now your exponential form is equals to z equals to r e raised to j theta, where your r is the magnitude, that is the square root of x squared plus y squared, and the angle theta is the arctangent of your y over x. Take note, this angle theta in exponential form is in radian form. Okay, to summarize, z is equal to x plus jy is the rectangular form of the complex number. You can also write that as r angle of theta, that is your complex number in polar form. That is also equivalent to r multiplied by cosine of theta plus j sine of the angle theta. Now that is r cis theta form. That is also equivalent to, that is r cis theta form. That is also equivalent to r multiplied by e raised to j theta. That's in exponential form. So we can have 1, 2, 3, 4, 5 forms of the complex number. Now in r angle of theta, we normally use degree, while in r cosine of theta plus j sine of theta, or we call that one your r cis theta, it can be a degree or radian mode. While in exponential form, you have to use the radian mode in your calculator. Any questions? Feel free to ask questions if you don't understand the topic. Okay, now let's proceed with the rules now of complex numbers. Now, what are the rules of complex numbers operation? So, like for example, when adding or subtracting complex numbers, we use the rectangular form. Take note of that. Adding and subtracting complex numbers use the rectangular form. For multiplying, for product and quotient of the complex number, we use the polar form of the complex number. These are the rules of the complex number. Okay, let's have an example for this. For example number 1, let's simplify. Now, if we are going to multiply two complex number in polar form, that's r1 angle theta 1 multiplied to r2 angle of theta 2, what will happen to the magnitude and what will happen to the angles? So if you are going to multiply that one, you are going to multiply the magnitude, and for the angles, you are going to sum it up. That will become theta 1 plus theta 2. That's how you simplify the product of two complex numbers in polar form. Okay, what about if we divide two complex numbers like r2 angle theta 2 all over r1 angle theta 1? What will happen to your magnitude? The magnitude will also be r1 r2 over r1, and then the angle will become theta 2 minus theta 1. Now what if now we will use the exponential form? Let's say simplify r1 multiplied by e raised to j theta 1 multiplied by r2 multiplied by ej theta 2. What will happen to the magnitude? That will become r1 r2 multiplied by what will happen to the exponent? That will become the sum of the exponent theta 1 plus theta 2. The same is true if we are going to divide two complex numbers in exponential form. Let's say r2 e raised to j theta 2 all over r1 multiplied by e raised to j theta 1. So the magnitude would be r2 over r1, that's the magnitude, multiplied by e raised to j theta 2 minus theta 1, because that is division. So subtraction, you add the angle. For division, you subtract the angles. Okay, this time, get a piece of paper. Before that, now we will solve some more examples. Let's convert z is equal to 4 plus j3 to a r angle theta, that is the polar form, b r, okay, that is r cis form, c we have r e raised to j theta, and that is the exponential form. So your solution is very simple. First, solve for r, that is the magnitude of your complex number. That 4 squared plus 3 squared square root, that becomes 5. And for the angle theta, you can have the arctangent of 3 over 4. Make sure now your calculator is in degree mode. That will be 36.87 in degree mode, or if you are going to convert that to radian, that is 0.64 radian. We need radian to represent the exponential form. Therefore, 4 plus j3 is equivalent to the polar form, that's for A, 5, z equals to 5 angle of 36.87. For letter B, the CIS form, z is equal to r, which is 5 multiplied by the cosine of the angle 36.87 plus j sine of 36.87 degrees. For the exponential form, we have z equals to 5. Now this time we will be using the radian value, 0.64. So you don't need to write the radian. Radian is unitless. Okay, that will be your final answer. Take note, we do not write e raised to j 36.87. This is a common mistake. No, that's wrong. Okay, this time you try this. Get a piece of paper and try to solve the problems below. You are going to simplify to rectangular form e raised to 4 times e raised to j pi over 4 plus 2 angle of negative 125 degrees minus 1 plus j3. That's your problem number 1. And for problem number 2, okay, you are going to simplify to, this time we will use the same rectangular form of, so 3 angle of 120 degrees divided by 4 plus j3 multiplied by 2 times e raised to j pi over 3. So you will be given 10 minutes, or rather 20 minutes. Okay, try to pause this video first and then try to get pieces of paper and try to answer the problems below. So you will have 0.68 minus j 1.81 in your problem number 1, and your problem number 2 will have 0.28 plus j 0.12 as your answer. Did you get it right? Okay, now for the next topic. For the next topic, we will be discussing the powers of the complex numbers. The powers of z. We call this as Demoivre. So Demoivre, that's moi, you pronounce that as Demoivre's theorem. Demoivre's theorem. In short, we can call that as DMT. Demoivre's is actually a French pronunciation, so you can call it Demoivre's theorem. Okay, now if z is equal to x plus jy, let's start from this rectangular form, and it is raised to a power of 2, what will happen now if we are going to convert that to polar form? That is still raised to the power of 2. So this will become r squared angle of 2 times theta. Or in short, that is r squared multiplied by cosine of 2 times the angle theta plus j sine of 2 times the angle of theta. Now, if we are going to raise z equals to x plus jy to the power of 3, that is the same as r angle of theta raised to the power of 3. That becomes r cubed angle of 3 times theta, or in r cis theta form, that is r cubed multiplied by cosine of 3 theta plus j sine of 3 theta. Now, what if we will raise the complex number to the power of n? That is z plus x plus jy raised to the power of n. That is also equivalent to r angle of theta raised to the power of n. That is r raised to the power of n, or the power of n angle of n theta. So that is the same if we write this in trigonometric form. Cos r raised to n cosine of n theta plus j cosine of 3 theta. By the way, we call this one as the trigonometric form of the complex number. R raised to n cosine of n theta plus j sine of n theta is the trigonometric form. We can also write this in general form as r raised to n theta plus 360 degrees multiplied by k. Take note, no? We have discussed that before. That is the general form. Now, if the angle theta is greater than 360 degrees, okay, are you ready for your next activity? Okay, try to solve this problem. So you are going to simplify to polar form 1.3 e raised to j 1.4 multiplied by 1.4 angle of 208 degrees to the power of 5. So you will be given 5 minutes to answer the problem. So try to pause the problem, try to pause your video first, and then try to answer the problem. Are you done? So the answer would be 19.97 angle of negative 178 angle of 93 degrees. That will be your final answer.